This video is about binary tree and different types of binary trees and how to represent the binary tree. So in the last video, we have already considered the definition of tree, right? In a tree, every node can have any number of children, right? Whereas a binary tree is a special type of tree in which every node can have maximum of 2 children. So one is identified as left child, the other is identified as right child. So in a binary tree, every node can have either 0 or 1 or 2 children, but not more than 2 children. So this is an example of binary tree. So here, this is root of the tree, right? Check out every node. So every node present in the tree got either 0 or 1 or 2 children, not more than 2 children. Now let's consider the definition of strictly binary tree. So strictly binary tree is a binary tree in which every node has either 0 or 2 children. So strictly binary tree is also called as full binary tree or proper binary tree or two tree. This is an example of strictly binary tree, and this is root of the tree. A is root of the tree, right? Check out every node. Every node is having either 0 or 2 children. Now let's consider the definition of extended binary tree. A binary tree can be converted into a full binary tree by adding dummy nodes to the existing nodes wherever required. So the full binary tree, which is obtained by adding dummy nodes to a binary tree, is called as extended binary tree. Now let's consider an example. This is an example of binary tree, right? What is binary tree? Binary tree is a tree wherein every node has either 0 or 1 or 2 children, right? Now the binary tree, we are converting this binary tree to a full binary tree. We are converting it into full binary tree. How we are converting? We are adding dummy nodes to the existing nodes wherever required. See, these are the dummy nodes. No data is there in this node, right? So that's why they are called as dummy nodes. We are adding dummy nodes wherever required, right? And making this a tree, binary tree, a full binary tree. So what is full binary tree? Full binary tree is a binary tree in which every node has either 2 children or 0 children. So the tree which we get by adding dummy nodes is said to be an extended binary tree. Now let us consider the definition of complete binary tree. A binary tree in which every internal node has exactly 2 children and all leaf nodes are at the same level is called a complete binary tree. Right? Now this is an example of complete binary tree. We'll check out how this tree is identified as complete binary tree. This is root of the tree, right? And we always say that root is at level 1, right? And the children of root at level 2 and their children's at level 3 and their children's at level 4. So tree contains 4 levels here, right? Check out every internal nodes. Every internal node. These are the internal nodes of the tree, right? Every internal node has exactly 2 children. And these are the leaf nodes. All leaf nodes are there at the same level, which is level 4. So this is a binary tree and it is also a complete binary tree. Now let's consider another example which is a binary tree, right? Another example, A is a root and got 2 children, B and C, and B has 2 children, D and E. This is a binary tree. but it is not a complete binary tree. Why it's not a complete binary tree? Because this tree is having two internal nodes, A and B. Both got two children, but the leaf nodes are not at the same level. See, this is at level 1, right? This These two nodes are there at level 2. These two nodes are at level 3. See, consider the leaf nodes here. This is also leaf. This is also leaf node. This is also leaf node. So the leaf nodes are at different levels. Right? C is at level 2. D and E are at level 3. So this is not a complete binary tree. Right? So what is a complete binary tree? It's a binary tree in which every internal node has exactly two children and all leaf nodes are at same level. Now let's see which binary trees are called as almost complete binary trees. An almost complete binary tree is a binary tree that satisfies the following two properties. First properties, all the levels are completely filled except possibly the last level. And the last level must be strictly filled from left to right. Consider these two examples, which are the examples of binary tree. Now we need to know whether they are identified as almost complete binary trees or not. Right? See, we'll consider this example first. See, this is level 1. Right? At level 1, we have root. It is completely filled. At level 2, we have two children for root node B and C. Right? It's completely filled. Now, in the last level, now the second property we have to check. See, the last level must be strictly filled from left to right. See, it is filled from left to right. Right node is missing in the last level. It is level 3. Last level, right node is missing. So this is almost complete binary tree. The first property is also satisfied. The second property is also satisfied. So this is an example of almost complete binary tree. Now check out this first example. Now at level 1 we have root, right? Level 2 we have two children of root. Next level 3, right? The first level is completely filled. Second level is also completely filled. The third level we have to check it. It must be filled from left to right, right? See here, but the left node is missing here, right? Right is present, left is missing. So that's why this is not almost complete binary tree. Let's see which binary trees are identified as skewed binary trees. A skewed binary tree is a binary tree that satisfies the following two properties. The first property is all the nodes except one node has one and only one child. The second property is the remaining node has no child. Right? So let's consider one example. Right? This is the first example. See every node got one child. Right? Every node. This is the last node, leaf node with no child. So this is a skewed binary tree. Every node has only left child. So that's why it is called left skewed binary tree. So consider the second example. Every node in the tree got only one child, right? And that too, it's a right child. Every node got right child. This is leaf node with no child. So that's why this tree is called as right skewed binary tree. Now which tree is called skewed binary tree? Third example we'll consider. Right? So this is a binary tree. Every node has one child. Every node has one child here. One child. Except this last node, which is leaf node. Right? This is skewed binary tree. It is called as skewed binary tree. Every node. See, A got left child, then B got right child, C got left child. Every node is having only one child. So this is called as skewed binary tree. Every node is having only left child, then it is called as left skewed binary tree. Every node is having only one child, that to right child, means this is called as right skewed binary tree. And if every node is having only one child, then it is called as skewed binary tree. Okay, thank you for watching this video.